Well, gas and pressure has an effect on the weather as well. So the atmosphere is composed of air, which is a mixture of gases, and it exerts a pressure. The pressure can change. And so when meteorologists are trying to predict what weather's going to happen, they're looking at low pressure areas and high pressure areas. High pressure is usually associated with clear weather, low pressure with unstable weather. We also see a difference in pressure as we change altitude. The number of gas particles in a given volume will decrease as you increase in altitude, right? So if you go up to Kings Canyon National Park, as you're driving up, you're getting higher and higher and higher, and the pressure of the air, atmospheric pressure, is decreasing. So the pressure is dependent on the number of particles. So if we look at these two, those look like mason jars to me. Look at these two jars. This one has more red particles in it, and this one has fewer. And if you can imagine all of these moving at the same speed and bouncing around, I think we can understand that in this one, there are going to be a lot more collisions with the walls of the container than in this one, right? More bouncing around. So one of the weird analogies I've used is, let's think about kindergartners at school. And so these are the classrooms, and the little red things are the kindergartners. So this is a classroom with a smaller number of students, and this is a classroom with a larger number of students. And the teacher stepped out for some reason, and the kids are just running wild. So as these guys run around, they're going to bump into each other, they're going to bump into the walls. But here, where it looks like you have like at least twice as many kids, there's going to be more collisions, right? So there'll be more pressure. As you're traveling up the hill to Kings Canyon National Park, you probably will experience what we call our ears popping, right? So you have an outer ear and a middle ear and then an inner ear. So here's your eardrum, which is a membrane that seals off the inside of your ear. The inside of your ear. But there's gas on both sides. So the inner part of your ear is connected down into your throat through your eustachian tube. But then this is sealed up. So when you get water in your ear, it's just water that's stuck in your ear canal. It can't actually go into your head, which is a good thing, right? If you have an ear infection builds up pressure inside and makes your eardrum bulge out. It doesn't feel good. What happens when you go to a lower atmospheric pressure, higher altitude, is that the external pressure now is reduced, but the internal pressure is staying the same. And so that's going to cause the eardrum to bulge inward, which, if you don't have an ear infection, is not going to hurt, but it might be a little uncomfortable, right? And so you yawn or you chew gum or something, which helps to open your eustachian tubes and allows the pressure to balance out. This is why babies scream on airplanes, because they have very little eustachian tubes and their ears are not good at adjusting to changes in altitude. So that kid that's screaming and making you crazy, they're screaming because their ears hurt really bad. So if that makes you feel any more sympathy for them. Then when you come back down, the opposite happens, and now you're getting more pressure outside and less pressure inside, and so your eardrum is bulging the other way. And again, you need to get your ears to pop to equalize that pressure. Any questions? How do we measure gas pressure? Well, this is the original way. It's a barometer. So you may have heard meteorologists, the weatherman, weatherwoman, refer to barometric pressure. That's the atmospheric pressure as measured by a barometer. It reads the barometric pressure. So this is an illustration of the original barometer. And so this was discovered, invented by Torricelli. So he took a long glass tube and filled it with mercury and then inverted it into a dish of mercury. Mercury is a liquid at room temperature. It's very dense. And so what happens is the mercury starts to come out of the tube. But then we also have the force of atmospheric pressure pushing down on the surface of it out here, which is trying to push it back in. If you do this with water at home, with any normal-sized thing, even a really tall, skinny vase, what you'll see is that the water just stays in there and you don't see any vacuum forming. That's because in order to see this with water, your glass or your tube has to be like 30 plus feet tall. So they use mercury because it's a more manageable size. You can see the difference better as well. And so what will happen is that the height of the column of mercury in this tube at sea level is 29.92 inches, or 760 millimeters, which is still kind of high, right? That's getting close to a yard. You can do this anywhere, and at sea level, you'll get that same height of mercury. And so then he took this, and it's like interesting thinking about how did he do that? Took this and walked up a hill, going to higher and higher altitude, and as he walked up the hill, the height of the column of mercury got shorter and shorter and shorter. And when he came back down the hill, it got taller and taller and taller, because the height of the column of mercury is proportional to the atmospheric pressure. So you can measure the atmospheric pressure by how tall a column of mercury is. And so that's where the unit millimeter of mercury came from. It's literally measuring how tall is the mercury in millimeters. Higher pressure, higher column. So they created a unit called a torr, named after Torricelli. 1 torr is equal to 1 millimeter of mercury, and that's a more unit-sounding unit, right? Length of an element, how is that a measure of pressure? That's kind of crazy. But we still keep using this. So now we just have an extra unit. So torr and millimeters of mercury are exactly the same. Different names for the same thing. Of course, we can measure pressure in other units, and we need to know how to convert pressures in different units. And I would give you information on an exam. So here, all of these things are equal to each other. This is the average pressure at sea level, average air pressure. So there's that 29.92 inches of mercury. Here's 760 torr, or 760 millimeters of mercury. That pressure is also called 1 atmosphere because it's the pressure of the atmosphere. It can also be measured in pounds per square inch, 14.7, or the official SI unit is the Pascal, which is a Newton per square meter, 101,325 pascals. You can do any pressure conversion in one step because you just pick the two that you need. So let's do an example here. Local weather report says the barometric pressure is 30.44 inches of mercury converted to PSI. This is dimensional analysis. So we are given 30.44 inches of mercury. We are looking for PSI. So I'm going to go from inches of mercury to PSI in one step. 30.44 inches of mercury. I've got one factor. I'm going to have PSI on top, inches of mercury on the bottom. Same thing we've been doing with dimensional analysis all semester. The way the pressure units will be given on an exam, the way that you find them in a table, is always going to look like this. All of these things are equal to 1 atmosphere. All of them are equal to each other. And so I'm just going to take the one I need. For PSI, it's 14.7. Oops. 14.7. For inches of mercury, it's 29.92. And then I'm going to multiply and divide. So 30.44 times 14.7 divided by 29.92. So I'm getting 14.95548, and it just keeps going. How many sig figs should this have? 3. So my starting number had 4, but this 14.7 is not exact, and so that's going to limit. So I'm going to take 3 sig figs, and this is going to be 15.0 PSI. If you're going between atmospheres and torr or millimeters of mercury, that's exact because that's how an atmosphere is defined. Any questions? Another way that can be to measure pressure is called a manometer. And this is used to measure the difference in pressure between the atmosphere and the pressure in a container. So here we have a high pressure gas in a container, and the manometer is this glass tube with mercury in it. And the other end is open to the atmospheric pressure. If we didn't have any pressure in here, we would expect the levels of the mercury to be the same on both sides, right? Because it's being pulled down by gravity, and the force is going to be the same on each side. So it'd probably be about here and about here. But you can think of this high pressure gas as someone blowing in the tube, right? And so they're blowing, this side goes down, the other side goes up. We see a difference in the heights of the columns because atmospheric pressure pushing down here is less than the pressure inside pushing down here. And so we can find the difference in pressure. If we know what atmospheric pressure is from the barometer, then we can figure out what the pressure is in here.